Welcome to the Coroutines Code Lab. In this Code Lab, you will learn the basics of using Kotlin Coroutines in Android apps to perform things like network requests. We put this video together as a quick introduction to coroutines on Kotlin. If you already know them from another language, feel free to skip it and go straight into the Code Lab. Coroutines are a new feature in Kotlin, but they're actually a pretty old concept. They've been used in popular languages for the last few decades, and they turn out to be a great solution to some common problems that we have on Android. Coroutines allow you to replace callbacks. You can transform callback-style code into what's called sequential programming. In this video, we'll explore how they do that. In addition to replacing callbacks, on Android, they also give us the ability to make our code main safe. And this means you can write coroutine-based functions to make a network request, for example, and just call it from the main thread, and everything will be okay. So let's write some code to make an imaginary network request. To make this interesting, let's start it on the main thread. If we write it in what's called a blocking style, where we return the result directly from the network request, it will block the main thread. This is a problem because a network request may take seconds or even minutes to complete. And the entire time that it's running, the main thread won't get updates or respond to touch. And the user will see your app as frozen. This is a really bad experience for the user, and we don't want to do that on Android. If instead we write the same function with callbacks, now our code won't block. Our networking library will take care of running the network request on another thread, and when the data is ready, it will pass the data or call back to the main thread. The callback is the handle the library uses to pass data from the background thread to the main thread. While callbacks are a great solution to async programming, they come with a few issues. They don't handle errors well without doing more work, and they can become overwhelming when too many callbacks are used in the same function. To solve these issues, we can use coroutines. Here's the same function written with coroutines. To make it work with coroutines, it becomes a suspend function. It looks just like it did when it was a blocking function. However, since it's a suspend function, instead of blocking the main thread, when network request is called, it will suspend the coroutine. This frees up the main thread to handle onDraw and user touches. And when the result is ready, it'll get passed back. Instead of using a callback, the coroutine will resume. Now, it's important to note that with coroutines, our networking library still uses another thread to run the network request, just like it did with callbacks. The main difference is the code tends to be simpler than the callback version. Now, you can think about suspend and resume as replacing callbacks. So when you call network request, suspend makes a callback from the rest of the function. So how does Kotlin do that? Let's take a look at how it executes. When Kotlin executes on data needed, it will execute it a bit differently on the call stack than a normal function. It keeps track of the place it starts the coroutine so that it can implement suspend and resume. Then it will call it just like a normal function, executing each line of code until it reaches a call to another suspend function. Before it calls the suspend function, it will copy the current state for later. And that's how Kotlin implements suspend. You can think of this state as a callback that knows how to resume the current function. Then Kotlin will run network request until it suspends itself to make the network call. Now at this point, all of the coroutines on main are suspended, so main is free to handle UI events. Fast forward a bit until the network request comes back, and Kotlin will resume these coroutines. First, it'll resume network request, and it does this by restoring the state it saved earlier. Once network request is done processing the request, it'll return to onDataNeeded. And the result is available immediately. If the network request failed, it would throw an exception right here instead. Then the coroutine will continue executing just like a normal function until it returns. Because coroutines allow us to handle long-running tasks without introducing callbacks, they tend to create simpler and more readable code. In the rest of this code lab, you'll explore how to integrate coroutines with architecture components to make a network request. We'll also touch upon how to make code main safe. And with that, let's suspend this video and resume the code lab.